Deep beneath the waves, in the crushing dark of the abyss, scientists have just found something, well, monumental. A hidden giant, an ancient force that's been silently shaping our planet's climate for over 15,000 years. And honestly, this discovery changes everything we thought we knew about the deep ocean.
For the longest time, this was pretty much the textbook view. The deep ocean was seen as this slow, quiet, almost boring place. Just a vast, passive container of cold water that didn't really do much. It was the predictable, unchanging background of Earth's climate system. But it turns out, boy, were we wrong.
So yeah, that old myth of a static abyss, it's been completely shattered. The new reality, revealed by this stunning discovery, is that the deep ocean is dynamic, it's structured, and it's an incredibly active player in regulating our world's climate. It's not a passive reservoir at all. It's a powerful engine. So you're probably wondering, how on earth did we find this thing? Well, the breakthrough came recently, and it's all thanks to a fleet of advanced technology. We're talking Argo floats and autonomous underwater vehicles that could finally probe the deepest, most remote parts of our oceans with a level of detail we've never had before. And what they found was just astonishing. Okay, so picture this. Deep in the South Atlantic, they mapped out this colossal body of extremely salty, dense water. It's a feature so distinct and so massive, it earned the informal name the salty blob. But this isn't just a current or some stream, it's a coherent, ancient entity that's been hiding in plain sight this whole time. And the sheer scale of this discovery is just staggering. First up, its age. The core of this water mass is over 15,000 years old. This is literally a relic from the last ice age, a time capsule from a completely different Earth. Then there's the salt. Its salinity is, well, it's off the charts. Over 36.5 on the practical salinity scale. That is way saltier than the surrounding deep water. And this extreme saltiness is the key to its superpower. It makes the water incredibly dense, incredibly heavy, and that allows it to sink and stay isolated at the bottom of the world. And okay, finally, the size. We're talking about a volume of approximately 1 million cubic kilometers. It's almost impossible to wrap your head around that number. This isn't a blob. It's more like a submerged continent of ancient water, a true giant of the deep. So we've got this giant, ancient, salty body of water. Big deal, right? What does it actually do? Well, its role in our climate system is huge. We can break it down into 4 key pillars, 4 distinct functions that show just how critical this thing is to the stability of our planet. We're talking about 4 incredible superpowers. Its amazing long-term stability, its ability to modulate ocean circulation, its massive capacity for carbon sequestration, and its role as a planetary heat buffer. So let's dig into each one. All right, pillar number 1, stability. You have to understand, the blob is essentially fossilized water, formed way back during the last ice age. Its extreme density creates this kind of force field, preventing it from mixing with the water above it. Plus, it's literally penned in by underwater mountain ranges, the mid-ocean ridges, which act like giant walls, keeping it locked away in the abyss for thousands of years. Pillar 2, it's a global anchor for ocean circulation. Think of it like this giant, heavy weight at the bottom of the ocean that literally helps drive the great ocean conveyor belt. It pulls water down, controlling the pace of the entire global system. It functions like a master valve, regulating the flow of heat, carbon, and nutrients all around the planet. Third, and you guys, this one is absolutely crucial. It is a monster carbon sink. See, cold, salty water is like a thirsty sponge for CO2, and the blob has been soaking it up for thousands of years. And the carbon it locks away, it stays there for over 1,000 years, which makes it one of the most effective and stable long-term carbon storage systems on the entire planet. And to put a number on that, scientists figure it's already absorbed somewhere between 10 and 20 petagrams of our carbon emissions. A petagram? That's a billion metric tons. So yeah, this deep sea giant has been quietly cleaning up at least 10 billion tons of our mess from the bottom of the ocean. And the final pillar is heat buffering. Because it's just so massive, the blob can absorb a ton of heat from the climate system without really changing its own temperature much. It's a planetary shock absorber, protecting us from really abrupt climate swings by soaking up all that excess heat and then releasing it super slowly, over centuries. So when you put it all together, the stability, the circulation control, the carbon storage, the heat buffering,
a really powerful idea emerges. The salty blob is, for all intents and purposes, our planet's ancient climate flywheel.
Now, if you're not an engineer, a flywheel is basically a heavy wheel. Once you get it spinning, it resists any changes in its speed. It smooths everything out, absorbs shocks, and provides stability to a machine. It stores momentum. And that right there is exactly what the salty blob does for our planet. It has this immense climate momentum. It's slow to change, and it resists abrupt shifts. By anchoring circulation, storing carbon, and buffering heat, it provides this deep, continuous stability to the entire planetary system. Okay, so why does any of this matter? This isn't just some cool science fact. The discovery of this hidden guardian has huge, immediate implications for how we understand, model, and, well, navigate our climate future. I mean, this discovery fundamentally rewrites the science. Before the blob, our climate models had all this uncertainty about how much carbon the ocean could absorb. Now we can make them way more accurate. Before, we couldn't fully explain these abrupt climate shifts in the past. Now, we're pretty sure features just like the blob were the key modulators. And here's the kicker. Our current climate models, the very tools we rely on to predict the future, they're completely missing this gigantic piece of the puzzle. They just don't account for this massive reservoir of carbon and heat. And that means our projections could be seriously off. We have to get this updated and fast. What this all boils down to is that tracking the salty blob's health, its size, its saltiness, its temperature, that's not a nice to have anymore. It's become a new vital sign for the planet. And monitoring it is absolutely critical if we want to accurately forecast what our climate is going to do in the coming decades. So when you step back, this is the story we've uncovered. The salty blob isn't some passive, dusty relic from a bygone era. It's an active, dynamic, ancient climate fighter. It's been down there, silently working from the darkness of the abyss, keeping our world stable this whole time.
And look, as our planet keeps warming up, the stability that this flywheel gives us is more important than ever. Understanding it, protecting this hidden reservoir, that's not just good science. It's essential for our survival as we try to navigate the massive changes that are coming.
Which really leaves us with one final and pretty urgent question. This ancient guardian has been our planet's silent protector for thousands and thousands of years. Now that we finally know it's there in a world that we are changing so rapidly, can we find a way to protect it?